Okay, this video is going to be for factoring polynomials with greatest common factor. Okay, so it's the first one right here. Let me move this out of the way. This one, greatest common factor. On the warm-up, he basically starts factoring and showing you how to factor. Right? You do the factor tree until you get to the prime numbers. If you don't remember what prime numbers are, you can Google it and it gives you the long list of prime numbers. Prime numbers 2, 3, 5, 7, 11, 13, 17, and so forth and so on. There's more, okay? But you can Google them, prime numbers. You can also use the calculator, guys. So right here, calculator, you can use the graphing one, which is Desmos. It takes you straight to Desmos. And you can type greatest common factor, GCF, parentheses. And the two numbers were, the two numbers were 36 and 45. So right here, GCF 36, 45, and it gives you the greatest common factor, 9. Okay? He did it the long way, but that's the shorter way to do it. Then he says practice sum. So right here is asking you for the greatest common factors of 84 and 56. So you type it in the calculator again. Let me see. What are the numbers? 84 and 56. 84 and then 56 is 28. The greatest common factor of 84 and 56 is 28. And so I had already typed it, and that's how you get it. Then you go into the lesson. So I'm going to click again the home button. Takes me back. And then now I'm in the instruction part. I already did the warm-up, so now I'm in the instruction part. And now it's going to give you instructions. And you're going to be watching the videos, okay? So let me pause this. So when I have letters now, I can still do the numbers in the calculator, 72 and 27. 72 and 27. So the greatest common factor of 72 and 27 is 9. Okay, so I know that it's going to be 9. But then we also have to do the letters. So if I do the letters, I'm going to do the letters of the first one. That says 2 A's, 1, 2, and 5 B's, 1, 2, 3, 4, 5. Then the 27 has, I'm going to change color, 3 A's, 1, 2, 3, and it has 3 B's, 1, 2, 3. What do they have in common? Okay, well, this one has 2 A's that I can take out, and this one has 2 A's that I can take out. So I'm going to take out 2 A's. Okay, and then this one has 3 B's. This one has 3 B's, and this one has 5 B's. So the most I can take out of both of them is 3 B's. So I'm going to take out 3 B's. 1, 2, 3. So what is that? That's A squared, because it's 2 of them, and B cubed, because that's 3 of them. That means that these two numbers have a square and a b cube in common. And we also found out that it was a 9, right? the calculator told me it's a 9. So the greatest common factor of these two is 9a squared b cubed. Okay, so make sure you're writing those notes down. It's going to ask you to do some example problems pretty soon. So this is the same thing. Let me pause right here. It's the same thing. They want to know, what do these two have in common? Okay, these two numbers, what do they have in common? Well, I can put 3 and 6 in my calculator right here. 3 and 6. My greatest common factor is a 3. So both of them have a 3 in common. That's why they have 3 right there. And then the x's, right? This one has 2. And this one has 1. So they have 1x in common, both of them. I can take out 1x. That's why they took out a 3 and an x. Okay? Then when you take it out, it's like dividing. So I have 3x squared divided by 3x. And then I'm also going to divide 6x divided by 3x. Okay? And that's how they got this and this answer. Because 3 divided by 3 cancels. Then you have 2 x's on top and 1 x on bottom. So it's like saying 2 x's on top, 1 x on bottom. So I can cancel 1 x on both. And that leaves me with just 1 x. And right here, the x can cancel with the x. And then 6 divided by 3 is 2. There was a negative in the middle, so that's why it's -2. Okay? So he's going to do more examples of things that don't have a greatest common factor other than 1, right? So like 3 and 5. If I put it in here, 3 and 5, the greatest common factor is 1. That means I cannot take out a number, but I can take out letters. So right here I have 4 m's, and right here I have 1 m. So how many m's can I take out? I can only take 1 out of both. Okay, then you have 8 n's here and 1 n here. How many can I take out of both? I can only take out 1 n. Okay, because this one only has 1 and that's all I can take out. So if I can take out 1 m and 1 n, what do I have left over? So if I take out an m from this one, that's going to leave me with 3 m's left. And if I take out an n from this one, that's going to leave me with 7 n's. And I still have that 3 in the front because 3 divided by 1 is 3. So I'm left with 3 inside, 4 m's, and 7 n's, minus the 5 stays right there. And then if I take out an m and take out an n, I don't have anything else left inside right there. Nothing's going to be left. Okay, so just continue working. If you have any more questions, I can make another video, but just keep practicing and you guys can get the hang of it.